Good morning. Wenangu waliku? Wanaenda sleep over? For 1 week. Techu pwecho nomba. Okay. First of all, I'm not too sure why we're even still having this topic here. I think we did a lot of this in second year. Yeah? A lot of it in second year. Filtration. In fact, you've been learning about filtration since when? Huh? First year, right? So anyway, I think today will be one of the shortest meetings. I don't think we're going to do 30 minutes plus. Yeah. You see, let me have your attention. I love it when people are happy that there's no class, eh? Because my exam, I'll be happy looking at you, just, you know. So much as you are happy that we're not meeting as much, you've got your own time to do your own sleepovers. Make sure when you come for that test, for that exam, you do your stuff. I've always told my students that for third year students, trust me, I have no intentions of keeping you here. If you are coming back for a SAP, if worse, you're coming back for an E, to be honest. I have no intentions of keeping you here. So around my circles, I try to make sure that much as I am moving, other people are moving as well. So the more I have people, worse off that I'm teaching, stagnate, it does something to my spirit, and that's bad. So sometimes I have looked at some question sheets, is it answer sheets? Maybe someone is missing about maybe 5 marks or so. Just go, you know what? You figure it out in the field, eh? But then there are times when it's really hard because you've given these people the very questions, and then you bring the same questions in an exam. They fail, so you begin to think. Is it that maybe they never used to study? They just packed everything and then they just... So guys, my third year, I know I've been here before. It's cozy, right? It's cozy, you're almost done. You've cleared 2 years. Actually, 2 years and the semester, just one more remaining. So it takes you in this comfort space. But like I always say, the comfort zone is where dreams go to die. Eh? So be careful with the space that you have. In third year, that's why I see people gaining. First year is oil, and the second year, maybe they were picking up. But in third year, that's why I'm always confused, because there's one face that I'm seeing 1 week. The next week I'm seeing this. Is this the same face I saw? All right, so it's the comfort that you're getting in third year. But with that comfort, try to be more responsible. Okay? Make it easy on us to mark your papers. All right, so filtration of what? What do we know about these things? I don't know why we're even talking about this, huh? Anyway, I'm just here to give you a guidance because I really think that you guys can study this document on your own, right? Hello, bamene bakamba yes abo. Okay, so filtration. What do we know about filtration of water? What do we remember from second year? What is filtration of water? Yes, sir. What's your name, sir? Richard. Yes, Richard. Okay. Well, there are many processes attached to that, but I want you to be more specific when we are filtering. What's the process involved in? Yes, madam. What's your name? Yes, Messi.
Filtration is the process in which water, which has suspended solids or particles, passes through layers of soil, that's groundwater, sand, and gossip.
Okay.
It also helps to reduce stability and also to remove those particles which escape.
I hope we got what she said. Anybody else with a different view? Anybody else with a different view? Yes, sir. What's your name?
Charles.
Yes, Charles.
Filtration of water. This is the removal of impurities in water by lowering its contamination. Can either be a physical process or a chemical process.
Okay. Through the purification process, at what point do we filter? Yes, sir. After sedimentation and coagulation. Why do we do that? Why do we do that? Guys, when you go for interviews, these will be questions they'll be asking you because these are practical. These are things that commercial utilities go through. I mentioned that hydrology, water supply, these are things that are a part of you. So when you go for interviews, they'll really ask things that they are also seeing on the ground and expect you to know these things. Yeah? Yes, Mercy?
There are actually 2 points when you filter. That's when water is being drawn from the source, where it passes through 2 types of screens. That's coarse screen and I'm saying there are 2 points at which water is filtered. When water is being drawn from the intake plant, it passes through 2 types of screens. Then the other point is when water is leaving the sedimentation.
Water is leaving the sedimentation tanks. What is and I've talked about that. All right, so let's just write some key points that I would want you to take home. Even as you study, these points should really be loud. Okay, so let's write this. Sedimentation tanks remove a large percentage of suspended solids. By the way, this is water supply, not hydrology. Sedimentation tanks remove a large percentage of the suspended solids and organic matter present in raw water. A large percentage of suspended solids and organic matter present in raw water. Present in raw water. Are we there? A large percentage of suspended solids and organic matter present in raw water. We there? Full stop. So you can just make another point. The process of coagulation, and this is the previous topic we just touched. The process of coagulation of water further. The process of coagulation of water further. The process of coagulation of water further assists in removal of impurities. The process of coagulation of water further assists in the removal of impurities. So we say when water comes in, we give it time, detention time, and the idea is just to allow whatever solids or suspended solids that are able to settle to the bottom to do that. Okay? But then this process is not enough alone, because there are some sediments that no matter how much time you give them, they won't settle to the base. Okay? So if that is the case, and those solids or sediments are known as colloids, all right? So we're going to have you okay, let me just say these are colloids, and we talked about how colloids, no matter how much time you give them, they won't settle. So what you do, you added a coagulant, right? And the last time we met, we talked about just the science behind the aluminum sulfate, which is very much common amongst the CUs that we have in Zambia. Okay, so these are the colloids that make it here. And then once this is done, you add in a coagulant, flocks will form, and those that are heavy enough, they go to the bottom. Still, there will still be those that are, yes, stubborn, but then even just the colloids, the flocks that have been formed, they also need to go through a medium of a bed of sand. This is where water is allowed to just filter through. And ideally, you're supposed to have bigger stones or gravel, as she put it, and then they reduce in that nature. Okay, so when water passes through, it's filtered through a sand medium, and then you have to find a way of extracting this water that has been filtered down here. Okay, so that's the entire process. Okay, let's just write this statement as well. The process of water passing through the beds of granular materials. The process of passing the water through, the process of passing the water through the beds of granular materials is known as filtration. The process of passing the water through the beds of granular you know what a granular material is, not so. We talked about this in second year, I think. Granules, from granules, those are granulars. Basically just sand, gravels, yeah, the grains, okay? So if we're passing through the beds of such of a granular material, this is known as filtration. Okay? One last statement from the introduction of this topic. The filtered water is potable and palatable. The filtered water is potable and palatable. The filtered water is potable and palatable. And it is free from various undesirable impurities like color, and it is free from various undesirable impurities like color, odor, turbidity, pathogenic bacteria, etc. It is free from various undesirable impurities like color, odor, turbidity, pathogenic bacteria. So, okay. Perhaps the only interesting addition with the material in third year compared to second year is there's just a bit more technical language, a bit more technical explanations as to why we need to filter and what filtration really entails. Okay, so that being said, we are all expected to know about the theory of filtration. Theory of filtration. Theory of filtration. Theory of filtration. So the theory behind it, like I say, I can explain to someone in a bit more details. And at this level, it's expected that we know that. Okay, so let's write this. It has been noticed from experience. It has been noticed from experience. It has been noticed from experience. It has been noticed from experience that during the process of filtration, the following effects occur on water. The following effects occur on water. Effects of filtration on water. Okay, so this is you trying to get a bit more in detail with how you explain things to someone. Have I ever mentioned to you that, if I've never mentioned, but probably you should have heard this before, that 70, others even stretch to 80% of people's success has to do with their communication skills. And I always tell people that, look, if you are I'm uncomfortable talking in front of people, you need to change that mindset. Yes, genuinely you could be, but make an effort not to seem like you are not comfortable. A lot has to do with how you communicate. A lot has to do with how you brand yourself. So you guys are going to go out there in the fields. Probably there will be an advert. A couple of you will be invited. Who they settle for? Yes, grades will give you that attention. Oh, can we hear what he says? But then if we bring you and then you just don't communicate, you don't show us how much you know, we begin to doubt. We begin to think that, well, probably either in Zokopa or they're just good at repeating and regurgitating, or what's that word I'm looking for? Offloading what they would read, study, and then they just offload. Your ability to talk, your ability to communicate the things the way they are supposed to be heard takes you very far. The reason why I'm saying that is when you talk about the effects of filtration, and I always give examples of lawyers, it's just about the language that they have. There's nothing special about those guys. I hope there's no one with a relative who's a lawyer in here. Yes, they are smart, but they sound smart because of the language, the rate of the speech, or is it the speed of the speech? It's their vocabulary. These guys are smart. But I think if I had to compare to, I think what we do as engineers. I mean, engineers, we solve new problems on a daily basis, right? Law is mostly about what has happened before. And I can assure you there's no problem you're going through that nobody has ever gone through. So they go read back the stories and their cases, and then they find the right ways of going about that situation. So pay attention to the words, to the terminologies, the phrases, and all that. Also, when you present your final projects, there literally is a column where we mark you based on your technical language. Are you getting me? Literally, like in your phrase, in your presentation, we pay attention to how many engineering phrases or terms did this person use. So start paying attention to things that are of engineering sound or tone. Okay? All right, so let's understand the effects of filtration on water. So yes, we push through down water, but then what effects exist on water when we do that? So one, the suspended and colloidal impurities which are present in water. The suspended and colloidal impurities which are present in water. The suspended and colloidal impurities the suspended and colloidal impurities which are present in water in a finely divided state are removed to a greater extent, which are present in water in a finely, so finely, just the same terminology, right? Finely, which are finely divided, which are in a finely divided state, are removed to a greater extent. So remember, your water came through, you sedimented, the colloid stayed up, you added an alum, further those that were able to come together, they sat down, but then there were those that still remained. That means they are very fine, and I don't know how they even made it there. But when we filter, they are greatly removed. 2, this is another effect of filtration on water. The chemical characteristics of water are altered. The chemical characteristics of water, the chemical characteristics of water, the chemical characteristics of water are altered. The chemical characteristics of water are altered. 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 A-L, sir. A-L-T. Altered. Mwamvera chani guys on. Eh? Eh? At their orchard. The hell is that? Alter day, to alter, to change, to give it a different molecular integrity. All right, so the third one of how filtration affects water, the number of bacteria present in water is also considerably reduced. The number of bacteria present in water the number of bacteria present in water, the number of bacteria present in water the number of bacteria present in water is also considerably reduced. The number of bacteria present in water is also considerably reduced. So should a question arise where I'm asking you how exact filtration affects water, I would expect you to list those 3 and then add a bit more information exactly how you fully understand those. These have just been stated, but when you get down into the module, they've been explained. Twamfana. All right, so after those 3 points, just write this statement. The theory of filtration to explain why such effects take place. The theory of filtration to explain why such effects take place. The theory of filtration to explain why such effects take place is based on the following 4 actions. Is based on the following 4 actions. Is based on the following 4 is based on the following 4 actions. So for actions, I can just say explaining theory of filtration. And the module really gets down in details to explain what these are. So 1, mechanical straining. Mechanical straining. Mechanical straining. Mechanical straining. So the 3 effects of filtration on water can be explained by the following. 1, mechanical straining. So when you're explaining how filtration affects water, and for instance, you state the first point that we mentioned, right? you should marry it to the 4 points here. So mechanical straining, I think it's a no-brainer because of the beds, the sands, and just how they are arranged. And you're pushing through water, you are mechanically straining the water itself. 2, sedimentation. Sedimentation. The 3rd one is biological metabolism. Biological metabolism. As you also have your metabolism. Electrolytic changes. Electrolytic changes. So the module sort of dives a bit more in depth of what exactly we mean by mechanical straining. So for instance, I'll read 1 point, the first one. For mechanical straining, you don't need to write this. The suspended particles which are unable to pass through the voids of such grains are arrested and removed by action of the mechanical straining. That's about it. For sedimentation, and this is very interesting, the voids between the grains of filter act more or less like small sedimentation tanks. So when you're talking about sedimentation, in the theory of filtration, what they mean is that when you arrange your grains in the way that they are, they'll still have their voids formulated. There are still spaces in between those voids, and those spaces can literally act as sedimentation spaces. So if it's a void, water will go and settle there, and then you expect that if that water's got a bit more of some colloids or anything less than that, can settle down. Okay? Biological metabolism. So the growth and life process of a living cell is known as biological metabolism, and the action of filter is explained in the basis of Okay. Yeah. All right, let's talk about filtered sand, or sand that is used for filtration. So let's just call it filter sand. There's a point I feel we didn't stress enough. Now, we need to revise this material. Okay, so let's write something about filter sand. So the filter sand is classified on the basis of the filter sand. The filter sand is classified on the filter sand is classified on the basis of its effective size and uniformity coefficient. The filter sand is classified on the basis of its effective size, okay, and the uniformity coefficient. Uniformity coefficient. Uniformity coefficient. So we're trying to get more information on the type of sands that you want to have in your bed as you are hoping to filter this water. Okay, so let's write something about the effective size. So with those 2 points written there, you can just go to the next line and say, the effective size of sand indicates the size. The effective size of sand. The effective size of sand indicates the size. Who also takes you in soil science? In second year, right? Yes. Miss Oliver? Yes. Do you do any practicals? With the sieves? Yes. Ah, so this sounds very familiar, right? Yes. Okay. So the effective size of sand indicates the size of sieve, indicates the size of sieve in millimeter, through which 10% of the sample, of sand, through which 10% of the sample of sand by weight will pass. Through which 10% of the sample of sand by weight will pass. Through which 10% of the sample of the sand by weight will pass. So these are some, this is like a technical language you can use just to show someone that you can work on a project that has to do with filtering water. So you go and tell them that, look, sir, if we're looking for sand for your beds that are going to filter water, you have to pay attention to the effective size and how uniform those sands are. When it comes to the effective size, whatever sample size we get, 10% of that by weight needs to pass through a sieve. I have very much confident he would have never heard that from anywhere else. And when you put it that way, he knows, and you're already beginning to buy into his psyche that you know what you're doing. So pay attention to the details, some phrases that are very rare. Also for guys, try to sound smart for your crush. They'll give you some attention, eh? In my time, there were guys that would, I think I've mentioned this to you, maybe the other class. In my time, there were guys that were nutritionists. We have new freshers coming in. They'll go back to them and say, "Much into the engineer." By the time the youngster is learning that this guy is not an engineer, all right? So the point is, our language is unique. If you speak with engineering terms, you would stand out that this guy is talking differently. Okay? And the majority of the human race, we are driven by intelligence. I don't know, but I'm sure you've at least encountered a phase or a scenario where you look at someone, they are appealing by sight, and then you get close to them, you have a conversation, you go like, right? But again, the opposite is true. There are those from a distance, you look at them, why is this person, so you go like, there's something about this person, I don't find them attractive, but when I talk to them, they are appealing. I don't want to mention names, but on social media in Zambia, we have celebrities that you can categorize like that. You look at them from a distance, but they've done things, they talk things, and then you're just drawn, and then they've got numbers. All right? A lot has to do with how they're communicating and how they're presenting themselves. That being said, I have seen a good number of, I hope I don't get quoted for this, a good number of ladies that shouldn't ideally think they'll get married faster than the others. Chapita? So, Kurivamushe Navajawadishe so are we together? So ideally for men, we are driven by what we see. So you don't hope that the ones that are looking the part, they'll get the jackpot, right? But you find that sometimes it's just the average ladies that will do that. Usually this all comes down to how they are presenting themselves. Either Vamusha, they already think that Dinoamusha will just do nothing and just be. And then those that feel like they need to compensate for what's missing, they get their attention, right? So communicate better, all right? Just communicate better. I hope Chapita Zungumanje. Chamvega. So effective size. So pay attention to the language. So effective size, there's a size that works. So this will take you to uniformity coefficient. Uniformity coefficient of sand. This is the ratio of sieve size. This is the ratio of sieve size. This is the ratio of sieve size. This is the ratio of sieve size in millimeters through which 60% of the sand. Okay, but this semester na ponzi sir. Yeah? I've tried. So I've got 2 classes with you. I also have a class with the first years. It's too much, eh? Yes. No, but like I said, the goal is to retire. Yes. Oh, next semester they're not seeing me. Well, next semester there are different courses, so I may put in the same level of input. But that other year, so 2025 mid-year going that way, I am officially retiring. Whoever I'm having as we're having a class, I'll be coming here, introduce myself. Through the class rep, I send the links to the YouTube channel videos, send assignments when they're done watching, then see you in an exam. Yeah? Irichea. Because the videos are clear, the materials is the same, nothing is ever changing. I'm tired. I've been lecturing since 2014 when I came in as a tutor, you know, in the game, and I'm doing the same thing. Even in business, I say if you're going to remain doing the same over a period of 6, 7, 8, 10 years, you're not growing. You are not growing. So there should always be something that makes your work easier, you become more efficient, you divide your time, you're being in various places. Ideally, I was supposed to quit, and I mentioned this to my boss, but then I said, no, you don't need to do that. We still need a civil engineer on the team as a department. Just figure a way of lecturing and still do your stuff, because you being out there, the experience is what we want you to bring also in the classroom. So I said, cool, this G is a cool guy, eh? So it doesn't stress me. So it's just about, did you lecture? Cool. Did they write an exam or a test? For now, I've been saying yes, though I haven't yet given you. Where the results, I'll give you 2 weeks before the exams. Cool. All right, so where was I? Through which 60% of the sample of sand by weight will pass. 60% of the sample of sand by weight will pass (60% of the sand by weight will pass to the effective size of sand. Through which 60% of the sample of sand by weight will pass to the effective size by size. So when you talk about uniformity, you want your granules to be of the same size. Are we together? And I'm talking about if this is a layer of sand, for instance, these granules should be the same size. Are we together? If they are different, as in maybe if we cut here, we have a uniform movement, and then on the other end, there are smaller and bigger ones. What you expect is that where there is no uniformity, water won't move at a constant rate, because the smaller spaces, for instance, have been filled up by even smaller granules. So water won't run at the same rate as it is running on the other side. So you always want to make sure that your sands are uniform. And how do you do that? There are sieves. So if you're maintaining a 10 millimeter opening, then everything that passes there, you sieve it, and then you check, for instance, maybe what just gets returned. But you cannot just pick any form or type of sand and put it there to work as a straining bed. So you have problems with water running through constantly. All right, classification of filters. Mwalema. TVC, eh? Yes, madam.
The question on the sand.
Uh-huh.
Is it just any type of sand, like these common types of sand that we have? There's a special type of sand.
There is a special type, because also it's not just about it being uniform. It has to have a certain quality. There's a quality that can be uniform, but then it breaks under pressure, and that's a problem. In Zambia, I'm not sure if we do have, but the last I checked, you need to import that sand from South Africa. And also, that type of sand can actually be manufactured. If you want, not in Zambia, but in SA, if you want to have really perfect workings of the filter bed. I saw a hand?
Yes.
Okay.
I think you said that sand that they use is Dana sand. That's the name of the sand.
It's called Dyna sand, right?
Dana sand.
Yeah, so we can get more information on that about that, but it's not just any type of sand that we can get. All right, classification of filters. So filters are in different classifications. We have one, slow sand filters. We have a slow sand filter. Slow sand filters. Slow sand filters. 2, rapid sand filters. Rapid. Imumakolewa mukazi wa mani nkatema kai. Rapid sand filters. So I'm hoping on that point you won't forget it. So after stating or mentioning those two, the next line just say the rapid sand filters can further be subdivided. The rapid sand filters can further be subdivided as 1, gravity type rapid sand filter. Gravity type. Gravity type. Gravity type. Gravity type rapid sand filter. And then 2, pressure type rapid sand filters. So, if you have you started working on your projects, by the way? You are done. You mean your projects are done? When did you begin your research? Last semester. So you have you are done. Even reports are there. Huh? So you're doing reports now? Okay. And you haven't done any presentations yet? Yeah, so this is something that I wish someone had told me earlier when I was doing this, the standing in front of people. You learn so much from yourself by watching yourself. Aganiza vina ngojae. If you haven't, there's something about standing in front of people that you can do certain things that the body and the mind is not aware that you're doing. I know that's... So what I can advise you, and this is, I've seen this really working, get a phone. All of us have got nice phones these days. Put it there, okay? And then do a PowerPoint presentation of what you're doing. Present just for 10 minutes. Watch yourself. Trust me, you will be amazed that I do that. By the way, this is you being alone. When you are standing in front of people, it's a different ballgame. But if you practice enough on your own and watching yourself, okay, maybe I'm moving my hand gestures so much, or I'm not maintaining eye contact, because that is very important, by the way. When you come to present, we want to see your eyes looking at us. It shows that you're confident. But from experience, I've noticed students will, because there's a projector there and then there's an audience and then they're literally just looking at the board. Like just, not even what I've done, just here. If they come back, they'll come and look down and then just, that doesn't inspire confidence, okay? So practice, watch yourself. Mr. Ongola would tell us a time, I think I was in first year, that look, if you are unsure about how you talk like, just go in the woods and just give a 5-minute speech to the trees. But I have thought that take it even further, just record yourself doing that. So you pay attention to the sound of your voice, you pay attention to the volume, to the tone of your voice, to the speed or the rate of your speech. Everything needs to be in order if you want to communicate effectively. You can't speak too fast. You can't speak too slow. You can't be too loud. Are we together? But trust me, when you come to present in front of an audience you're unsure of, you will be surprised how your voice just goes up and you'll be shocked that you are that loud. Others are just way too loud. So I was saying, this is my project and then can't get you, especially for the ladies. So, sometimes I like to give a preview of people's future so that they prepare adequately, because these are things that I'd wished someone had told me. But through watching my videos and the stuff that I've done, I have sort of perfected that, and it's a tip that I always tell people, just watch yourself. All right, any questions, Nalema? No, Nalema.